Okay, so welcome back to my YouTube tutorials. Today too, I'm going to take you guys through advanced calculus 2. Okay, so I have this question over here which I would like to work with you guys. So the question says that given that r of t equal to 2t exponent 3I plus the natural log ln tj minus 6tk. Then the A part says find a tangent vector to the curve at the given value of t equal to 2. Okay. And then the B part 2 says find the second derivative r of t at t equal to pi. Okay. So I have here a solution. Okay, so I have to just repeat the question again, which is r of t equal to 2t exponent 3I plus ln of t g minus 6tk. Okay, so whenever you are asked to find a tangent vector to a given curve when t is given, okay, or when a value say t is equal to 2 is given, your focus here is to find the first derivative of the question. Then when you are done, you do the substitution aspect of that. So let's go ahead to find the first derivative of this particular vector question. So we have the first derivative r prime of t equal to 2. This is t exponent 3. So the 3 will drop down, come and multiply the 2. We have 3t exponent, then reduce the exponent by 1, so minus 1. Okay, then I plus, this is a natural logarithm ln of t. So if you differentiate this, you are going to get 1 over t j minus 6k. So this is the first derivative. We have r prime of t equal to 6 t exponent 2 I plus 1 over t j minus 6k. Okay, but the question says that we should find a tangent vector to the curve at the given value of t equal to 2. So we have to do substitution over here. So we have to find r prime of 2. This time around not t but 2, because we are substituting the value of t into the question. So we have 6 multiplying with 2 exponent 2i, okay, 2i plus 1 over 2j minus 6k. Okay, this is a constant, so it doesn't have t attached to it, so we maintain it like that. So we have r prime of 2 equal to 6 multiplying with 2 exponent 2 is 4, giving us 4 here, I plus 1 half j minus 6k. So r prime of 2 equal to 6 times 4 will give us 24. So 24i plus 1 half j minus 6k. So after doing the substitution, we got this particular answer. Now, our focus here is to determine the tangent vector, okay, to the curve. So our r prime of 2 will now be 24, comma 1 half, comma minus 6. So this is the answer to the given question E, okay. So this is the answer to that. Now let's move on to work for the B part. Okay, we are going to work for the B part, which is the second derivative of this question here. So hopefully we have gotten the first derivative, which is this. We are going to uh, continue from there. So the first derivative of this is 6t exponent 2i plus 1 over tj minus 6k. So to find the second derivative, we are going to get r prime prime of t equal to 6. This 2 will drop and come and multiply the 6. We have 2, okay, t, then the 2 exponent 2 will reduce by 1. Then we have I plus, this is a quotient, okay, it's a fractional uh, function. So if you are trying to find the derivative of this, you can use the quotient rule. So if you do that, you are going to get minus t, then minus 1, okay, then j. And this is a constant. Derivative of a constant value is 0. So we ignore that part, okay. So now we have r prime prime of t equal to 6 times 2 will give us 12. Then t exponent 2 minus 1 will get t I, okay, minus t exponent minus 2, okay, j. So the second derivative of this is giving us 12 ti, okay, 12 ti minus 1 over t exponent 2 j. So now our final answer to this particular question is this. But then the question says that we should find a second derivative at t equal to pi. Okay, so we have to do a substitution here. So r prime prime of pi is going to be 12 multiplying with pi, okay, minus 1 over pi squared, okay. So we have, sorry, it's a vector, we are dealing with vector, okay. So j prime prime is equal to 12 pi I minus 1 over pi square j. So writing it in a vector form nicely, we have r prime prime of pi equal to, okay, this symbol simply means we are putting it in what? Vector form, okay, minus 1 over pi square. So this is the what? The final answer to this particular question. So from here, you could see we've been able to find the first derivative. We did a substitution, we got this, and then the final part to the second derivative, we have to substitute t equal to pi. So whenever a question is given to you, and then like this one particularly, they say find the tangent vector to the curve at the given value of t equal to this, okay. It's not necessary will it be t, but this is vector. We are dealing with what? Vector value function. So whenever the question is given to you and you have to substitute value, in this case your focus is to find the first derivative. After that, then you do the substitution, okay. Then the same apply to the b part. You have to find a second derivative. After getting it, then you do substitute the value of the value given to you, okay. So the question says second derivative. If it is third derivative, you do the same thing, then you go ahead to do the substitution. So that is it. Thank you for watching this video. I'd like you to subscribe, share it with your friends, like, and also don't forget to click on the notification bell so that whenever I upload a new video, you quickly get the notification. Thank you once again. Goodbye.